So let's start first part about the session 1 to 3. Okay, it is about introduction of C++ in the context of the OpenFOAM. Okay, so let's look at few of the things in terms of the C++. Okay, that is needed and that is in and out about the OpenFOAM. Okay, so in the OpenFOAM all this concept is used. Okay, so if you have awareness about that, it may be helpful to you to understand the coding or understand the style of the coding inside the OpenFOAM environment. Okay, so let's start with this session 1. Okay, so when we talk about this C++ programming, okay, at that time certain things is very essential, so that one has to understand one in terms of the programming is concerned. Okay, so very important aspect is following. So data type and declarations, how we can define the different class of the data type. So the data type is not only the variables like integer, float or double or all these things, but also the bundle of the variables and the functions. So in terms of the C++, we call it as a structures or classes, how we can define the class and the all these things. So that is come under the data type and the declarations. Then control structures. Okay, so that is also very important. Then functions, array, pointer and type defined and classes. Okay, then certain template libraries and some useful observations about the OpenFOAM in terms of the C++ programming. We try to look at that, and some basic class that is very important in terms of the OpenFOAM. We try to explore certain of this all the things during this discussion. Okay, so when we try to look at the any of the basic program, okay, so if we look at not only OpenFOAM, let's say we want to write our own new program in terms of the C++, what we require. We required one thing is the text editor. Okay, so where we can able to type our required code, okay, whatever we required. Then we require the compiler, and then after the compilation we get the executables, and that executable we able to run it. Okay, so in terms of OpenFOAM, how it going to work is something like this way. So in terms of the OpenFOAM, if we see, okay, so let's look at here. So in the application we are developing our new solvers, so that is our own develop the code. Okay, so let's look at, let's say ICO-form. Okay, and this is our so main file. So this is our file, so this is our main code. Okay, and inside of the code we write our all the statement or all the things what is needed. Then what we require to compile this code. So for compilation we are using the wmak command, and we able to compile this code. After compilation, what we going to achieve is the one exe file, and the name of exe file is nothing but the ICO-form. Okay, and this is the exe file or executables that facilitate the calculation of our all test cases. Okay, so that is how one can see the basic program. Okay, or for any class of the C++ programming, that is the basic things needed. Okay, so when you talk about the basic structure of the C++ program, we have certain include files. Okay, so that include files is required, that will facilitate the certain variables creations or certain new class, or we adapting certain things from different class. Okay, all these things is needed in terms of the this include file. So when we talk about the OpenFOAM, and if you again go back to the ICO-form, this is the include file. We say we include the fvcfd.h. when we include fvcfd.h, what going to happen? It will try to facilitate all the required peripheral .h file that is needed for the execution of our this own code. Okay, so that is with the help of the include, we are allowing the all existing libraries and all existing classes to inline with our requirement. Okay, so this is the few include file. From here our main code going to start. Okay, and here this is few more additional include file is needed. But if you look at here, we have a this include file, then we have a using namespace std. Later on we understand what is mean by namespace. Okay, but this is the space that will initiate the basic aspect in terms of the standard C++ concern. Okay, then we have a main program. Okay, or here we try to execute sorry, not execute, but we define our main source code in with int main, okay, and this parenthesis allow us to facilitate the writing within this bracket whatever we want to execute, or whatever the solver we are developing, we have to write within this area. Okay, so this is the our very simple and basic structure about the C++ program. Okay, so always there is some include file, some namespace. Okay, in terms of the OpenFOAM, our namespace is always OpenFOAM, or few more namespaces available. Okay, so if we want to exactly explore what different class of namespace is available, we can quickly observe from the Doxygen as well. Okay, so this is the namespace. Okay, namespace, we have a FVC as a namespace. Okay, so that is how one can see the different aspect. Okay, so this is the namespace we define, use namespace as a form. Okay, so this is what we define, and when we call for fvcfd.h file, in it try to call or try to include all the other include or dependent files that is needed for the execution of our solver. Okay, so that is inside of it only we specifying the namespace. Okay, using namespace of form. Right. So now when we talk about this basic structure, okay, so let's have a few more things in terms of C++. Okay, so when we talk about this data type and all these things, okay, and the some variables, so we have a different type of the data type, like boolean operations, characters, integer, floating point, double floating point, some valueless or wide character. Okay, so this is different data type is available inside the C++. Okay, so it is facilitate us to manipulate certain variables and to take into account certain values for the variables, and some logical operation if we want to do, then we have to define in the certain ways. Okay, so for that all the data type and the its declaration is needed. Like if we want to go with the int, okay, so integer is ABCD, that means it is a integer values. Okay, so int a declaration initialization at a time we can specify. Okay, it will only read the integer part only, even though you say 5.12, but AA is defined as integer, it only going to read as integer part only. Then we can define the float as a pi. Okay, and then we can initialize it. So here there is a multiple ways, either you just declare it, okay, and you declare along with you initialize also. What is declaration? We can say so and so variable is integer, so and so variable is float, so and so variable is behave as a double float, and all this thing. But when we assign certain values to that particular variable, okay, at that time it's called its initializations. Like here we say pi is a float type of the variables. Okay, and we then specified pi with the certain values. Okay, so it is called its initializations. Okay, so we have a declaration and followed by its initializations. Okay, so always there is initialization is required for each and every variables. Okay, so that is our basic part. Okay, now there is a certain few more aspect like character, integer, double, type, few like here if we see, okay, so here we have integer and the float. Okay, so float is nothing but give you the entire digital type of the variables. Okay, in the similar line we have doubles. Okay, so if we want to retain the number of digit in for a long digit, then we go with the double type of the variables. Okay, and then character, if we want to define the certain names, then it goes under the character behavior. Okay, so this few things we can define. Okay, so let's say when we say signed variable, unsigned variable, okay, so if it is a unsigned init, then we have only positive value. If it is signed init, then we have a positive and negative both the value. Okay, when we define with the long and as a prefix, okay, then we have a chance to retain the more digit as well. Okay, so few aspect about its different data type. Okay, then we have a different operators, okay, like arithmetical operators, logical operators, okay, that is about and or. Okay, then we can have a assignment operators, okay, and then we have a certain miscellaneous operators. So this all operators is useful to create our new equations, and based on the equations we can add up certain functions, creation, all these things. Okay, so for that purpose it is important. Okay, now before we go towards a few more aspects like loop conditions and all these things, let's explore certain things from the this C++ as a language, as a book. Okay, so let's start with this basic structure. Okay, so when we talk about the structure of this any of the program, okay, so we can say that let's include the some IOStream file. So IOStream file is facilitate the this reading and writing of any of the strings. Okay, so that is what needed. Okay, and init main is the main block and the main functions, so it always have a one functions. Okay, so any of the C++ program minimum one function it has, it is this where from where it is called the main functions. Okay, and through that main function we able to call the multiple functions whatever is needed. Okay, so that is and this is the standard way of outputting the any of the string. Okay, so that is std c count, and this is what it going to look at as a output here. Okay, so when you compile it and when you execute it, you will see this as a output from this one particular program. Okay, so in this particular online book you will see the description of each and every line that is mentioned here. Okay, so I suggest please go through it. Okay, and it is a very nicely written and very simple way to look at the basic aspect. Okay, so something when you go towards the our own developed code, or when we are looking somebody else developed code, so this comment is very essential. So what is mean in within that particular portion of the code, if we want to say in, or we want to document inside our .c file or .h file, then we must have a habit to create this class of the this type of the comment or some type of the note within the .c or .h file. Okay, so that's why here they are mentioning about the commenting. So you have multiple ways. If you want to comment on the single line, then you have a double line and you can comment it, or if you want to comment entire one block like this way, then like that way you can comment it. Okay, so then we have a namespace. Okay, so in C++ code, okay, we normally have this namespace. Okay, so namespace is facilitate all the declarations. Okay, so that is the idea. So we, with the help of the namespace, we able to define the certain declarations. Okay, so that is the idea. So it's always facilitate the certain class of the declaration. And in the OpenFOAM we have a namespace of the form. So under the umbrella of form we have all different libraries and everything we build up. Okay, so that's why we in the most of the time we have namespace form, and under that we try to develop certain things. So if I want to give you quick example, so let's go to, let's say, src file. Okay, finite volume FA field, we are aware about this patch. Okay, so let's say we are opening this file. Okay, sorry, let me open set the genie. Okay, so if we look at the .h file, okay, so .h file, it's always start with the namespace form. Okay, and under that namespace form we try to facilitate all the different functions, variables and everything. Okay, so when we look at any of the code, we have always there is a two file. One is called the .h file, another called .c file. So .h file facilitate all the declarations. Okay, all different variables, whatever is needed, okay, all different functions, constructor, member functions, everything goes inside the .h files, okay. And then we have .c file. So inside the .c file we try to initialize that all the variables with the help of the constructor, okay, and we have a total exactly the code that is execute the our required functions and everything we try to declare. So declaration goes inside the .h file, and the code exactly goes inside the .c file. So whenever we want to declare some variable, we normally don't declare within the .c files, okay. You can do that here before this, but it is not the good way to look at the programming. It is not a clean way to look at the programming. It's better we try to declare whatever is needed, okay. So we try to declare whatever needed inside this .h file, and we include that .h file here. So when you included, what is going to happen, whatever you define inside of this, it is now in line with this .c file, okay. So you able to access all the variables, all the functions that you define inside the .h file, and you can use that inside the .c file, okay. So always you can see both these files in all the directories of OpenFOAM, okay. So that is the normal way to look at that, okay. So Namespace going to facilitate the environment, and through which we going to execute our all the solvers, or we develop our libraries, okay. So that is basic structure. Then the same way all the variables, okay. So we have a few fundamental variables you can define with the different ways, like character type, okay. So character type, we have a character or character 16 underscore t, character 32 underscore t, w character, so exactly 1 byte in a size and at least 8 byte, okay, no smaller than it is little bit bigger, so 16 byte, 32 byte, okay. So depending on the size of the our character, we have to define this, okay. Same way integer, signed short integer, okay. So at least 16 short, 16, 32 bit, 64 bit, okay. So then unsigned, okay. So we can say unsigned character, unsigned integer, long, okay. Then we have a float, double, long, okay. So depending on our requirement, we can choose the floating point type of the variables, then boolean operators, then void type, no storage, and null pointer, declaration of the pointer, okay. So this is what we have. When we talk about the 8-bit, so 2 to the power 8, the size of that particular bit is represented by this way, okay. 64 bit to the 68, that is the its particular size, okay. So this is few things is defined in terms of the this variables, like how to declare the variables, okay. So here we are declaring the variables different ways, and so exactly in the code how it going to happen, we first declare the variables, okay, and then we assign the value, okay, and then we execute or write a one equations, and then we take a output of that, okay. So that is what we can say, okay. So how to initialize the variables, so type is this one. What is mean by type, okay. Type is nothing but all this mean by type, okay. So we have a different class of the type, either it is a integer, float, double, character, all belong to the type, okay. What type of the variables we are creating, then identifier, it is the name of that variable, and initialization value. So this is how one can declare and initialize the value at a time, okay. Or you can straight away initialize like this way. So multiple way you can initialize the variables, okay. So either equal to, or you can define it like this way, or like that way, okay. So it has a different name, okay. First known as a C like initializations, okay. Then it is called constructor initializations when we are, and this is uniform initializations, okay. So that is the initialize with the value 3, initialize value 3, then 2, and then determine the value. Okay, type of the auto, and so at a time you can declare, okay, auto that is same as a this one. So auto, whatever the you have this value, same way it going to add up for the new variables. Okay, so then into the strings, if we want to introduce the strings, so we can say that string is equal to my string, and in the my string we specify this. So when we are working with the string is nothing but the certain lines, okay, with the different character. So sometimes we try to use these strings to facilitate certain IO. Okay, IO is nothing but input output of the any variable or anything. Okay, so that is about variables. Then constants, okay, so we can specify the values to any of the variables, so it's behave like a constant, unsigned, signed, long, double, all these things. Okay, so this is how floating point numbers, okay, you can, how you are specifying. Okay, that is what in terms of the C++, okay, different things. Then when we have a /n, then it is defined as a new line character. Okay, carriage return, tab, variable type, backspace, okay, all these different things one can see. Okay, so that is what available. So when we say this one, okay, this is nothing but new line character. Okay, nothing else. So in new line character we define like this way as a character, and here we write it down, or you can straight away write here in the continuation in the same character. Okay, and it also going to work in the similar line. Okay, so this is certain constant. Then operators, okay, so we have a assigned operator is equal to, okay, so whatever you define equal to it applicable. Okay, then arithmetical operator, we have addition, subtraction, multiplication, division, and the module. Okay, that is we all aware. Then compound assigned operator, y is equal plus equal to x, that is nothing but y equal to y plus x, x equal to x minus 5. It is all compound operators. Okay, then incremental operator, plus plus, okay, this is, or minus minus, this is incremental or decremental operators. Okay, so 3, and y is plus plus x, that means it's nothing but the 4. Okay, same way. Then relation and comparison type of the operator, double equal to, that means equal to, not equal to, less than, greater than, less than or equal to, greater than, and equal to. Okay, so this is the meaning of all the operators we have. Then logical operators. Okay, so we can so normally for this logical operator either it is true and false. Okay, so that is what going to happen with the logical operator. This is Boolean operator, not, okay, this is not, equal to, okay, and or, that is the idea behind that. Okay, so logical are used when you will two expression to obtain a single resultant result. Okay, at that time it is AND operator, or this is called OR operator. Okay, so A and B, true true, okay, so true false ultimately. Okay, if the left hand side expression is false, then combined result is false. Okay, if the left hand side expression is true, combined result are true. Okay, so that is what, okay. Sometime we are checking this operators inside the if conditions. Okay, so I is less than 10 and plus 11, I plus I is less than n. Okay, if both the condition is true, then only it goes inside of this, otherwise it will not go. Okay, so that is what we are checking. Okay, then we have a question marks type of the operators. So conditions, if it is correct then goes with this, otherwise goes with that. Okay, so like that way. If 7 equal to 5, okay, conditions correct, and for evaluate to 3, since 7 is not equal to 5. Okay, so 7 is not equal to 5, correct, So that means it give you the answer of 3. 7 equal to 5 plus 2, it is correct, that means give you the answer as a 4. Okay, like that way. So that is then comma operators, so that is sometime needed in filling the some vector quantities. Okay, bit wise operators. Okay, so and, or, XOR, not or, shift bit left, shift bit right. Okay, then we have explicit type casting operators. Okay, so we explicitly defining the its type. Okay, so int, okay, I equal to int of f. Look, first we define the first we declare the I as integer, then we define the f as this value, and it is called explicitly typecasting operator. So we say I equal to integer of f. Okay, so that is what we have. So this is, then we have a scope operator. So normally we going to use this in the when we talk about the class and all these things. Okay, then prefix and suffix, prefix, incremental and decremental, function form. Okay, prefix, pointer to members. Okay, so some pointers we are using, then we can use either this way. Okay, then arithmetical, all the operators. So all these things is mentioned here, so you have a quick look of all the different aspect about the different operators and logical operator, arithmetical operator, everything it is mentioned there. Okay, then basic input output. So this is belong to the IO operations. Okay, input output operations. Okay, C in, C out, C error, C log, standard input string, standard output string, standard errors string, and standard logging output stream. Okay, so normally when we are developing our own solver, we try to use this C out. Okay, but inside the OpenFOAM we are using different aspect. Like if you look at here, for the output we are saying info. It is the with the help of the info, and we specify this. Okay, so how it going to work? Prefix as /n, it goes in the new line. Okay, so output is only starting time, and after this also we get a new line. So this is new line character. Okay, so and in between we are saying start time loop. So on the console it shows this output, and with the help of the info command. So in the similar line here, info time equal to runtime, and NL it, okay, and so it goes on the new line. Okay, that is how one can see different aspect here. Okay, so this is few things like here, new line. Okay, and it goes NL. Okay, end of the statement. Okay, that is like here. Okay, please enter an integer value. We didn't define any of the new line, so whatever you take a input, okay, immediately please enter this value. We enter this value, so we then say the value you entered is this. Okay, and its double is this. Okay, and then we say new line. Okay, so that is how one can see. So few aspect about the input output. Okay, so this is very essential where we want to write the data. Okay, without this IO nothing but input output. Okay, we cannot take into account this our output character or output variables, or we want to write inside our output files. Everything is belong to this basic input output. Okay, then program structures wise, if we see, then we have statement and the flow controls. Okay, so that is how one can see. Okay, statement, so we have a multiple statement. Okay, statement is this is one statement. Okay, so this is another statement. Okay, so this is conditions, and behind that, sorry, this is condition, and behind that there is a statement. So when we select the if and else, so if condition is satisfied, then it goes with this. Okay, otherwise it will not go inside of it. Okay, that is the idea. So if else, if condition satisfied, it goes with this, else it goes with that. Okay, we have multiple if else, condition satisfied, statement executed is this, else try to check this condition, if not then go with this. Okay, then for loop. Okay, so for is another, it's called iterative loops. Okay, so something like this way, for loop or the while and the expression and the statement. Okay, so n equal to 10, we say n is greater than or equal to 0, till that whatever is inside it try to execute. That is the idea. So it, what we say, we initialize n equal to 10, so at the beginning n is always greater than 0, so it try to give you the output equal to n equal to 10, then we say comma, then we say minus n 9 8 till is, and then we say count equal to, it's go come out, and we say count is left out. Okay, so that is the while and the expression statement. Okay, so then do and while. Okay, so do until this is true. Okay, so enter text hello hello until unless you type the this text. Okay, it will not come out of it. Okay, so that is the do and while checking. Then for loop has a three things. One, we say, look, initialization, condition and increase, and the statement. Okay, so initialization is execute like we initialize with certain variables, and we have a condition, it check these conditions, and this is the its incremental or decremental part. Okay, so whatever we seen like do and while. Okay, so in the same way, same thing you can finish with the help of the for loop. Okay, that is what we say, initialize with the 10, condition we check n is greater than or equal to 0, and this is the increment or decrement. That is what we can see, like this is our condition, n equal to 0, I equal to 100, n is not equal to I, and n, and this is our increment or decrement. Okay, so initializations, conditions and the increment. Okay, so then we go with the some range also. Okay, declaration and range and the statement for. Okay, C string like this way. Okay, jump statement. Okay, so break, sometime if we want to come out of the loop. Okay, so this loop is continue, but when it satisfies this we can come out of it. Okay, so it is called break, count aborted when it reach n equal to 3. Okay, so it's going lower and lower, but when it reach it will come out with the break statement. It is called jump statement. Continue statement. Okay, so when if n equal to 1 we say continue, so it continue till it goes till end. Okay, then go to statement. Okay, we can say go to the my label. Okay, if n is greater than or equal to 0. Okay, so there is few things one can do. Go to the my label you define here, so and it goes again here and finish the task until unless it satisfy this condition, it goes always my label. Okay, my label we defines one additional name, you can define any of the name, it is not necessarily only my label. Okay, then switch statement like case 1 2 3. Okay, so case switch x. Okay, so case 1 count x, c out equal to x is 1. Okay, then break 2 3 4 like that way, and if else equivalent you can say x is equal to 1, then this, equal to 2, then this, else this. Okay, so this is how you can see the break statement. So certain loops and the statement that normally we use inside the code, it is, one can see like this way. Okay, then functions. So function is the very essential part inside the C++. We normally don't write everything in a single functions, we try to break down the longer code in the small code. Okay, with the help of the this very nicely defined certain functions. Okay, so functions, how it's look like, it is type, name, certain parameters and the statement. Type is the type of value, returned by the functions. Okay, either the functions after the execution is returning the integer value, float value, double, or the no return, that is void. Okay, name is the identifier by which the function can be called. Okay, so functions has a particular name, then parameter as many as the argument that functions can take from the where it is calling and the statement. Okay, so that is how one can see, like let's say this is one function we define int, that means it return the value whatever is happening inside as an integer only, and function called additions. Okay, so that is the name, and the parameter it try to take int a and int b, and from the main program we are calling addition as a functions with the two argument. As many argument you have here, same argument supposed to pass. Okay, so additions phi 3, what it going to do from the main program, it try to call this addition. It is outside of main code as a small functions. So what going to happen, a take a value of 3, b take a a take a value of 5, b take a value of 3, and we define integer r equal to a plus b and return r. So return r, that means it try to return the int value, and that value goes inside the z, and we going to get output of 8. Okay, so that is what we have. So that is exactly going to happen. Then same way, let's say subtract additional one things we did. Z, we defined the int equal to x equal to 5, y equal to 3, and z. Subtract 7 minus 2. Okay, and we say z. Okay, then subtract 7 minus 2, we say this. Subtracts x minus y. So same functions, okay, we try to utilize for multiple operations. Okay, otherwise if we want to write it down, then so many times we have to write this same r equal to this minus this minus this. In case of that multiple operations, we can finish with the help of the same functions. By defining the functions, okay, we can utilize that function as many time as we want. Okay, so that is the idea. So function is very, very important candidate inside the programming. Okay, so then function with no type, the use of void. If function don't going to return anything, okay, so it is called the void functions. Like print message I am functions. Okay, it's not going to return anything here, it's not going to take any return statement, so it is a void type of the function. So void is nothing but it is the null type of the things. It's not going to return anything. Okay, of main. Okay, so return value of main, so the main always return as a 0 when it is coming out of it. So normally we say program was successful, it is the 0 return. Okay, so it give us the idea that program is successfully finished. Okay, so 0 exit success or exit failure, program is failed. Okay, so few output you can do. Argument passed by value or passed by reference. Okay, so whatever we are defining here, okay, you have multiple ways you can pass the argument. By value, okay, straight away you define this is as a value, or you can pass in terms of the its reference as well. Okay, so that is what we can say. So look, again come back here. So both the things is different, so try to understand. This is directly value is passed, 3 5 addition 5 and 3, and we here we say int a and int b, so it is called the pass by value. Okay, but here we are passing by the its, let's say duplicate is we define new function. So in previous case we say int a, now we say int ampersand a, int ampersand b. So this is by reference. Okay, parameter passing by reference, and when we passing by reference, what we're going to pass is the variable name. Okay, so that is what we say it is a. So this is by defining like this way. You can define argument by this way as well, and in terms of xyz you have to modify as a 1 3 and 7. Okay, so 1 3, when if you want to go with this by directly value, then you have to, in case of xyz, you have to pass the its exact value 1, 3 and 7, but this is by reference, so you can specify by the this variable itself. Okay, so normally in OpenFOAM we work with the by reference and as compared to by value, because value is always changing, but the variable name is the better way to pass the argument. Okay, that is what we can see. Okay, string. Then inline functions. So inline function is a specifier. Okay, so when we are calling the functions, okay, it's going to jump from one location to another locations, but with the proceeding inline specifier, so what it's going to do, please look at proceeding a function declared with the inline specifier inform the compiler that inline extension is preferred over the usual function called mechanism as a specifier functions. Okay, so when we want to use these functions, we try to use this in terms of the inline as compared to the another class of the functions. Okay, so here we say this is we are specifying by value. Okay, default value functions. Okay, and okay, sorry, I don't have a here example. Okay, here only. Okay, then we have default value parameters, so we have a default value of some defined as a b equal to 0, b equal to 2, that is the default value inside the functions. Okay, and we have only one, you can have a one argument or the two argument. Okay, so when division, if this goes only one argument, it understand that it about the a only. If you pass two argument, then it going to understand it about this also. But if you don't specify this argument, here it try to take this default value, so it is, that's why it's called default value parameter. Okay, so default value is 2. When you pass this value, it overwrite b equal to 4 and try to execute a by b, that is 20 by 4 equal to 5. This is the output you're going to get. Okay, so this is different thing than declaring the functions. Okay, so sometime we can declare it. So when we declare it, is called prototyping of the functions. Okay, so it is called first we declare and then we use. Okay, so here declaration of the function is a prototype. So when we declare the functions, okay, it is called without its actual body or the function body. When first here look odd and even, we first define these functions. Okay, from the main code we are using that functions either odd or even. Okay, but here we are defining it. Okay, so definition, prototype and the declarations. Okay, so it is called the prototype where we are defining the functions. So normally first we define the functions, okay, and then we declare the functions. Okay, so that is what we can see. Then recursivity, so few more functions, factorial or all these things. So this is the functions is very important character inside the C++ programming. Okay, so it has a multiple way you can look at the functions. Okay, then overload and the templates. Okay, so overload and templates is very important aspect. Okay, so operation overloading, this is the power of C++ programming, I say. Okay, that's why it's called object oriented and object oriented type of the things. So why it is object oriented, we can define the small segment of the code as an object in terms of the functions. Okay, and that functions we can use for n number of applications in. So that is why it is object oriented, and beauty about that is we can overload certain class of the functions. So with the same name we can execute multiple things. Okay, like here. Okay, so overloading function, if you see, we have operate int a and b. Okay, and we say operate double a and b. Okay, the whatever the value we are passing. Okay, so whatever the value we are passing, depending on that, it's immediately try to operate. So if you are passing the argument in terms of the integer, you go with this. Okay, so 5 into 2 10. If you are passing the argument in terms of the double, it try to do the as a operator like this way. So function name is same. but the execution is completely different. Okay, so that is what one can see. Okay, so that is the very nice way to look at the this overloading type of the thing. Overloading function may have a definition something like this way: functions, okay, so int sum. Okay, so here we can depending on the argument, okay, it try to go sum only, but our parameter is different. Here we are passing the integer, then go here. Here we are passing as a double, it goes here. So it is called function overloading. Okay, and so sometime we can here we have to define in the multiple two time. Look, same function, same operation, but the different variable we define two times. If we want to get rid of this multiple type definition, then we go toward the template. Okay, so we say template, and whatever the sum type it's come, it automatically take into account. So we can say template parameter and functions declarations. Okay, so we said template class sum type. Okay, sum type equal to sum type A, sum type B. Okay, so whatever it going to return, if it is integer A, integer B, return integer. Okay, so that is how one can use that. Like here, look, we say template class T, okay, and T, then sum TA TB. So whatever we define as a template class here, it is sum. Okay, so we say k equal to sum int ij, so it goes as a int, so this become as an integer, return value also become as integer, integer A, integer B, it going to take into account. When we say h equal to sum of double f and g, what going to happen, t become double, so double and double. So that is what we have. In this case we have a use t as a template parameter name instead of some time type. Okay, it make no difference, and t is actually a quite common template parameter name as a generic type. Okay, so then we say t equal to result, okay, and result equal to a plus b, and return t. So that is whatever what is result, nothing but whatever the type we specified here. If it is integer, then result become integer. T is a double, then it become double. Float, then result become float. Okay, nothing else. So functions with the help of the template, it is a very nice way to define the multiple functions. Okay, look, first understand operator overloading. Okay, so what is mean by operator overloading? Same functions work on different class of different type of argument. Okay, so sum is function for integer argument and the double argument, but we have to define the function body multiple time. But if we go with the template, what going to happen? Same thing with the single function declarations, we can finish the multiple operations. So we say template class T sum ta tb. What it mean? Whatever the sum, here we say int, so pass as a int, so this class T become int, so T become int, that means int of sum int a int b. In this case T become double, so what happened? Double sum double a double b, exactly the same thing what we look at previously. You can finish the same task with the help of the simple thing. Okay, non-type template argument. Okay, so sometime we say template T int n, okay, and then return the value. Okay, so here we can specify certain values along with that. Okay, so nothing else. Okay, but it try to whatever the value we specified. Okay, so here is the value T fixed multiply of T, so here we say int, okay, and this is its value we are specifying. Okay, with the help of this it going to take that value of T. Okay, so we say fixed multiplier int 2 3. Okay, so this n equal to 2 or 3, and this value equal to 10. That is what you can see. Okay, so this is few things. So this template is quite often used in the OpenFOAM. Okay, so you try to grab that understanding. Then namespace visibility. Okay, so namespace is very important character. Okay, so name and such name entries such as a variable, function or compound type need to be declared before being used in the C++. Okay, the point in the program where this declare happen is influence its visibility. Okay, so to combine all the declaration at one place, what we specified, we go with the some type of the namespace. That is the idea. Okay, visibility, entire visibility of an entity with block scope extend until, okay, where is that statement? Yeah, sorry, here. Okay, so at a time, with the help of the namespace, you can define all the functions, variables and everything goes inside of that as a namespace. Okay, so that is the idea. Like namespace, my namespace is declared by this. So inside of namespace, whatever the class functions we going to declare, okay, it has a access of this namespace. That is the idea. Okay, so from this it try to adapt basic aspect. Okay, so that is what we have. So using of, so we say namespace first we define this value, the namespace second we define this value. Okay, then we use first, this is the scope operator. Okay, so we use the scope operator. From this first we are taking the x value and y value, and in the main program we are using that value, nothing else. Okay, that is what we are doing. Okay, so now correct. So use of this, or you can say use namespace first. Okay, when we say use namespace first, we count x and y immediately. You need not to think about this. When you say namespace, use namespace, what going to happen? All this variable is in line with your functions. Okay, here we didn't say use namespace, so look, we have to use the scope operator. Okay, but we can say use namespace first, so immediately you, without this scope operator, this all the variables is aligned with your functions. Okay, but if you don't use namespace, then you have to use the scope operator to access any of the object of that particular namespace. Okay, so that is the idea behind that, like in the second case. Okay, here we can specify multiple ways, like namespace use, then we say namespace second use. You need not to use the scope operator, immediately you can use that. So namespace new name and the current name aliasing. So namespace you can alias, so existing namespace can be alias with the new namespace while following syntax. Okay, so using namespace standard. Okay, fine. So this is about the visibility, where it going to access. Okay, then we have a few more compound data type like array, character, pointer, dynamic memory, data structure and other data type. Okay, so let's observe couple of these things. So arrays is very important inside the our programming. So normally we start with the count from 0, 1 to 4. We are not counting, we are not starting our count from 1 to 4, 5. Okay, so in the C++ we count, our counting start from the 0 itself. Okay, so that is the idea. So when we say any of the array has a 5 variables or 5 entry, we initialize the array like this way. Okay, so this is its declarations. Okay, so we declare the array, it has a 5 entry. Okay, so and the type of the array is int. Okay, and bracket we can say int for 5. Okay, and then we initialize the array. Okay, so name and the elements, how many element it has. Okay, it has a 5 elements. Now let's initialize that element with the help of the 5 value. When you initialize, what going to happen, first value goes in 0, 1 to carrier. Okay, so that is how you can see this thing. Okay, so multiple ways you can initialize the variables. Okay, even though when you have a 5 and you have only 3 entries, so other goes as a 0 only. Okay, and this is called the null or initialization with the 0 value. Okay, so you can, with the empty bracket, it goes as a 0 value. Okay, or straight away you can say empty bracket for number of variable and you can assign this. Access of variables, when you say f2 equal to 75, okay, so x equal to f of 2, it's going to take the value of 75. Okay, so that is the idea. Okay, we first declare the array. It is a total 5 element out of 5. Third element is 75. Okay, 0 equal to a equal to 75, f of a. Okay, so that is how one can use the array. So here we initialize the value. Okay, then we say n plus 1. So we are result equal to result plus all the summation of everything. Okay, so that is what we are doing. Multi-dimensional array. So 3 and 5. Okay, so first is about the rows, second is about the column. Okay, so that is what, so this is 1 3, that means second row and fourth column. Okay, so that is how you can access the entry. Okay, 0 1 2 3, 0 1 2 3 4. As a parameter also it goes. Okay, so this is try to look at couple of the things about this array from here. Remember two things, it's always start from 0. Okay, and if it is a multi-dimensional, first is about the row, second is about the column. Then character and sequence. Okay, so we have a characters. Okay, so hello character, how it going to write inside of it. Okay, so this is about the characters. Okay, so I suggest please go through this. Okay, whatever important I want to show you. Then pointers. Okay, so pointers is very very important. So sometime we not directly access that particular variable in terms of direct its value. We only try to access that variable in terms of its address inside from the memory. So it is pretty fast. Okay, as far as the program is concerned. So pointers allow us to access that from that particular address. Okay, address to the pointer is like this way. For is my variables. Okay, and we define, let's say my variable is 25. For is my variable and bar equal to my variables. Okay, so what going to happen is something like this way. So it is equal to, directly says its memory. Okay, 1775, and we say bar equal to my variable, it give you this value. Okay, so that is here it give you the memory index. Okay, we assign the value 25 to my variable, a variable whose address is memory, assign it 1776. Okay, so that is what definition operators. Okay, so it try to define this. Okay, so 4 is nothing but 176, and base we try to define it. Okay, and inside the memory, so we say 4 base equal to 4. Okay, and base equal to value pointed by the 4. So this is how we can access that value with the star. So ampersand address of operator and can be read simply by the address of, and is the definition of operator and can be read as the value pointers to by. Okay, so that is the value at that particular locations. Okay, so look, my variable 25, address to that is 174 is this, but when you say star of 4, it gives you the value equal to 25. Pointers you can declare with the help of the star, character, numbers, double and decimals. Okay, so let's look at int first value, second value, my pointer equal to % first value pointer equal to 10, okay, 20. First value is 10, second value equal to this, okay. So very quickly you can access by the this thing. Then p1, first value address of the first value, second value address, we say value pointed by p1 equal to 10, okay. So we are assigning the value. Then value pointed by p2 equal to value pointed by p1, okay, and p1 equal to value p1 and p2 equal, pointer is copied. Here we are copying the pointer straight away. So that's, and then we say p1 equal to 20, value pointed by p1 equal to 20. So multiple things you can observe here. This is how you can say pointer and array, okay, pointer and variables, okay. Pointer initializations, we have to initialize the pointer also. Then pointer arithmetics, we can say plus plus, we increase the pointers as well, okay. So incrementing, decrementing the pointers, okay. We equate the pointers and the count, okay. So pointer and the string values, okay, pointer to pointers, okay, void pointer. So please go through this area, okay, pointers. Then we have a dynamic memory. So sometime we have to allocate dynamically. What is dynamic memory? Let's say in OpenFOAM, if we see, we always changing our mesh size, okay, from 100 by 100, 200 by 200, 20 by 20. How dynamically our solver will adapt the assigned memory size or required array size based on our mesh generation. So that is nothing but dynamic memory allocations, okay. So that is very, very essential. We cannot specify at the beginning of the code, let's say u is one of the variable, it only has a size of number of cell equal to 1000. No, sometime we increase the size, sometime we decrease the size. To take into account that aspect, we have dynamic memory allocations, okay. So that is the beauty of this advanced programming language, okay. It allows you to dynamically manage all the declaration about the variables, okay. So that is the dynamic memory allocations, okay. And you can go through this and try to explore the number of ways to explore the dynamic memory allocations. So dynamic memory allocations, inside the memory we have a malloc, okay. Sorry, I don't want to go in detail about that functions, malloc, calloc, recall and free, okay. So that is all the dynamic memory allocation. So here we are dynamically allocating the memories to the variable of the class. So that's why we also have a destructor of the class as well. So when we talk about, we will come to know about that part, okay. Then data structure, okay. So data structure is something like a structure name, and inside that we can specify the variables and all these things. So but in the OpenFOAM we are working with the class as compared to the data structure, okay. That it is second level of data structure only, okay, but it is a most elegant way to write the multiple data as well as functions, okay. So when we talk about the data structure, we only have a access to variables, okay, but when we talk about the variables and the functions, that will facilitate with the help of the class. That is the difference in between, okay. Other data types, okay. So type define, so we can define the particular type with the help of the some existing type, okay. So type define existing type and the new type, okay. So that is what we can see as the definitions and the new definitions, okay. So type define is quite often used in the OpenFOAM to override its existing behavior, okay. That is what we can see. So that is the type define things. Now very important is the class, okay. So inside the class, so class are the expanded concept of data structure. Like data structure, they can contain data member, but they can also contain the functions as a member, okay. So data structure only contain the data as a member, but in case of the class is also contain the function as a member, okay. object is an instant of the class. Term is variable. A class would be the type and the object would be the variables. Okay, how to define the class is something like this way, so please understand. Class or the word is a structure, so we work with the class. This is a class name and his access specifier, access specifier 2, and member functions and the object name. Okay, so class name is a valid identifier for the class. Object name is the object list of the member of a object of the class. The body of the declaration can contain member, which can either be data or a function declaration or a optionally access specifier. Okay, so either you have a data or a function within it. When we work with this class, we have multiple ways to restrict the accessibility of either functions or the data structure with the help of 3 keywords. One is the private, public, and protected. So private member of a class are accessible only from within the other member of the same class. Okay, so that's when we say anything is private. Okay, so private member class are accessible only from within the other member of the same class. Okay, or other friends class, otherwise it will not access. Then protected member are the accessible from other member of the same class or other friend, but also from member of their derived class as well. Okay, but private, whatever the private member function, it not accessed by the derived class also. Okay, but the protected, it can access by the derived class as well. But when we say public, it is accessed from anywhere wherever the object is visible. Okay, so that is the different way. If you don't declare anything, then by default it's called goes as a private. Okay, so please understand that way. If you don't define anything, it goes as a private. So this is goes as a private access only. Okay, so let's look at this. So object name. Okay, so we this is class. From the class we construct the object. Okay, so let's say we have a class name rectangular, and for that we have a its private member is width and height. Public, we say set value with this, and this is from the outside of this class we can access this both the member. Okay, so declaration type called the rectangular is the class, and the object or the variable of the class is called rect. Okay, and with the help of the rect command we can access the things. Okay, integer. Okay, so how we can access, just check. First we say class we define. Okay, from here width and height is not directly accessible. Okay, but this set value and area is accessible. Okay, from here also we can say void rect. Okay, we can say non-return value. Okay, so set value, we have to define these functions. This is what function part of the this class, and we have to define these functions. Okay, outside of, so this is its prototype of the function, and we declare the functions. Okay, so set value, and what we're going to do with the set value, we say whatever the value is coming. Okay, here we assigning in terms of the width and height. After the assignment of width and height, we say whenever the area is called, it return the value width and height. Okay, so that is the idea. So please understand, from the main program we say, we first say rectangular is the rect. Okay, in case of here we specified is object, we say we construct the object as a rect. Okay, we say rect dot set value 3 and 4. Okay, so what it going to do, it try to, because look, this is access from the public area, and we assign the value here at 3 and 4, and but this is visible, this able to this is a private variable, but it is accessed by this class. Okay, so now the rect is become the part of the class, so it able to access the this value with the help of this set as a value functions. Okay, so rect, here we are passing the value and we are assigning the value to the width. Now we say area is accessible, so we say area is nothing but rect dot area. So when we say rect dot area, it what it going to do, it try to return width into height. First we assign width and height with this set value. Okay, so that is what exactly we access. But how we access this value, this particular functions. Here we prototype, but we want to use that function, so we use the scope operator for that. Okay, so scope operator, since whatever we use, he used in the definition of this set function value, okay, as 1. The scope operator is allow us to do that. Okay, there is a one class and two object. Okay, so let's say we define the one class. Okay, so rect is the same way, one class. Okay, value is also one class. Okay, and now we are defining two objects. So one object is rect and rect b. For set value 3 4, for rect b 5 6, and when we say rect area, rect b area, we are defining. So same class we can define multiple object out of it. Okay, so that's why one class and multiple object. Okay, then we here we it is a very basic way to define the class. Now normally when we work with, we always try to look at in terms of the structure. What happened in the previous example, if we call the member function area before having the called set value. Okay, let's say here if I don't define the set value, and we without defining the set value we say rect dot area, what going to happen? It going to fail, because we don't have a value for height and width. If we don't have value for height and width, it's not going to calculate the area. Okay, that is what going to happen. Undetermined result, since the member function height and width is never been assigned as a value. Okay, in order to avoid that, a class can introduce a specific function called the constructor, which is automatically called whenever the new object is called, new object of this class is created, allowing the class to initialize the member variable or allocate the storage. Okay, so normally inside the OpenFOAM we always believe in the constructor. Okay, so constructor, how it going to work, look at. So we say class rect as it is, same way. Okay, here so class constructor. Okay, so what going to happen, just check. So here we are constructing the class. So in first case, okay, so we say what we did, please look at. So we say set value, okay, and we say void and this thing. Okay, here what we did, we say rectangular, we say rect init. Okay, this is the constructor with the same name, please understand that way. Okay, so result of this example are identical to those previous one, but now the class rect has no member function set value and has instead a constructor that performs the similar action. It initializes the value of width and height with the argument passed to it. Notice here we have a rect, same name as a class become as a constructor for it. Okay, so this is how constructor is defined and it accessed by the public way. Okay, so now constructor same way, rect init. Okay, in case of the set value. Okay, so we have a, this is how we can define. Constructor cannot be called explicitly as if they were regular member function. They are only executed once when the new object, okay, of the class is created. Notice how neither the constructor prototype declared nor the later construct defined have value, return value, not even void. Okay, so what it means, if you look at here in the previous case, okay, here, so look, it is a function, not a constructor, so it has a void value as a return. But if you look at here, it don't possess any void value. Okay, either is a prototype place or at the declaration. So that is what it's saying. This is here we declare this is its prototype. At the prototype also we have void value, and in the declaration also we have void value. But in case of the constructor we don't have a void value, and at the prototype as well as the declaration, both the places. Okay, so that is overloading constructor. Okay, so sometime same constructor we want to use for different class of the argument. Okay, so that is normally happen inside the OpenFOAM. Okay, so same things we try to use for multiple purpose. So that is called the overloading type of the constructor. Okay, so either it return the different class of the value based on the requirement. Okay, so that is the overloading class of the constructor. So here it is very easy to understand. So let's say we define the one class as a rectangle. We have a one constructor empty argument with the two argument. Okay, so when it is empty argument, we can immediately assign the value like this way. It is called the default value, and it is by argument it can define by this way. So when we say rect equal to rect 3 4, it goes with this way, and say rect equal to rect b, that means it immediately goes with the default value. Okay, so that's why his 25, and here is the here 3 and 4, so area equal to 12, here 5 5, that is 25. Okay, uniform initializations, class name, object name, initialization values. Okay, so we can initialize the object with the uniform value whatever is needed. Okay, so radius, circle is the class, this is its constructor, and we defining the double radius equal to r. Okay, and this radius is the private functions, and r is the publicly accessed value. So from here we are defining radius equal to r basically. Okay, so uniform initializations. Okay, we need not to specify or set a value explicitly. In previous case, if you see, we are taking this value, but here what we did is here itself we define this. Okay, inside of the our class. So there itself we have it's called uniform initializations. Okay, so what we say, circle for when we pass argument 10, so what is going to happen, radius become 10. Okay, so for circumference equal to 2 pi r, so that is what is going to function from assigned init. Okay, or you can say straight away circle bar equal to 20, bows equal to 30, 40, uniform init. Okay, member initialized in the constructor. Okay, so we say rect init. Okay, here constructor for this class could be defined as usual, rect like this way, but it could also be defined using member initializations, either this way, any way you can define it. Okay, depending on, so there is a multiple ways. Pointer to the class. Okay, rectangular, say protect. So in case of this, we can goes in terms of the its pointer as well. Okay, so then arithmetic operator and few more things. So this is how we can see the different aspect of the class. Okay, I suggest please go through this very neatly and try to grab certain things from here. Okay, then overloading operators in terms of the class. Okay, so same operator we can use for different purpose. Okay, so that is called operator overloading. So normally it is used inside the OpenFOAM. Okay, so that is the idea behind that. So one plus operator, normally we can say this plus over a plus b, it is very simple, but we want to define the plus operator in terms of the vector. We want to add a two vector. Okay, so vector a and vector b, if you want to add, how it going to happen? So for that we say operator plus only, but we can overload the same operator in terms of, so when we look at the vector also inside the OpenFOAM, we go with the same plus sign for scalar as well as vector. We need not to do anything extra. Why? Because inside the OpenFOAM this operator overloading is predefined. So for that purpose we need not to worry about what is happening when we say two vector is added, like vector 1 and 2. Here this is both are, let's say, vector. Okay, so C vector is defined, and by this very simple operator overloading it give you the output very quickly. Okay, so that is what different class of operator overloading is possible. Okay, in terms of OpenFOAM. So please have an idea about all this concept about the OpenFOAM and the C++. Okay, so please go through these certain things. One very important thing is friends functions and inheritance. Okay, this is very important aspect. So friend functions, when whatever the function we say it is a friend of that class, it has direct access to its private functions as well. Okay, so friends of rect duplicate. Okay, and it has a, when we say this, it has a direct access to its private member as well. Okay, so that is the idea. Okay, so this is friend functions and inheritance. Okay, so inheritance is very essential things inside the OpenFOAM. So same multiple time we want to write this program. Okay, so in case of that, we can inherit the features with the help of the simple thing. Okay, so that is the inheritance about the multiple class. Okay, so inherit class, derive class name and public class name. Okay, and based on that we can inherit the different aspect. What it mean by inherit different aspect? Look, we have to read the this value multiple time. Okay, so either we inherit that particular set value from the polygon. Okay, so look here, width and height, every time we have to set this value, okay, equal to width and height. Okay, so from the this polygon we construct the rect as a, when we say we construct it, we need not to write it down again and again. So whatever the features polygon has, new class also possesses the same feature. That means this is accessible by this particular inherited class. Okay, so a rectangle and the triangle has an inheritage the polygon feature, that is the set value. Okay, so that is why when we say rect set dot value and trang set dot value, okay, it try to directly use these functions even though it is not available inside of this class. But when we say inherit the features of polygon inside the rect with the help of this particular single colon syntax, okay, that is what it is here, derive class and publicly accessed class. Okay, so that is the things. One, with the help of this same inheritance, what it going to do, it try to add up the features that is available in the already old class, and from that it try to develop the new features and inherit the old features. Okay, so that is the how we need not to write same things again and again. Okay, so that is the idea behind that. One can has a multiple inheritance like rect, public polygon, public output, everything is possible. Like look, polygon it has, output it has. Okay, so we can say rect new class we define is rectangle, public polygon, public output, and then we declare the class. Okay, same way triangular also. So whatever the features this polygon has, it inherit in the rectangle, output features inherit in the rectangle. Okay, so that means this all the functions and the variables is accessed by the rect itself. Okay, so that is very important aspect inside the class, as far as the class is concerned inside the C++ inheritance. Okay, so we need not to define the certain class more number of time. Okay, so that is a few things. Please try to explore a couple of the things. Okay, so I think most of the things I covered from that web page only. If let me see if I miss anything, then this is all the loop and all these things. Okay, then function declarations. Okay, then type parameters, all the things. So by argument and calling by value and calling by reference. Okay, so that is what one can see. Yeah. Okay. So type define in the C++ allow the definition of our own type based on other existing data. We can do this using the keyword type define. So many times we are using this type define. Okay, so sometime it is very useful, okay, to define the things. Okay, so then protected private member functions. Okay, in the this is very important in the OpenFOAM. This 5 basic class is very important class, like polymesh class, fvmesh, okay, field algebraic class like field, dimensions and geometry. Then FV patch field derived, and FVC and FVM. This is the very important class. Okay, so when we talk about the basic class, okay, how to define the different operations in as far as the matrix and the tensor is concerned, that is defined in terms of basic tensor class. Okay, so that all the information, if you want to look at, you can access that informations from this area. So where it is coded in src OpenFOAM. Okay, primitive variables. Okay, inside the primitives, let's say we want to explore about the vector, go to the vector, and here all vector related things is defined, and .h is its declarations. Okay, so we look, Namespace is this template class T. Okay, so whatever is coming as a T, it going to take that value as a T, that is the template class, template compt. Okay, and this is some static variables. Okay, and we are defining certain new derived class from that, type of rank, symmetry of rank. Okay, and its functions is defined here. Okay, so many things you can access that particular entry of that particular vector. Okay, how to read that entry. Okay, how to access that entry. Okay, how to take a value from the tensor. Okay, dot, all these things you can explore from this area. Okay, so that is what tensor 1 2 3 8 9, you want to explore the that particular value x z. Okay, that is x and z. Okay, that is this value you can access very quickly by this way. Okay, and then the dimensions, we know that we normally work with the dimensions with the dimension of all the variables. So dimension is defined in terms of the 7 numbers. So mass, length, time, temperature, quantity, current, and the intensity. Okay, so that is one can define like this way. Okay, and it's behave as a, if it is tensor, you can define like this way. Okay, all the algebra, okay, or discretization is defined in FVM and FVC. Okay, so let's have an idea about that aspect very quickly. So that is the implicit derivations. Okay, so when what are the discretization, you go with the implicit, you go with the FVM. What are the derivation, you go with the explicit, you go with FVC. It is the explicit derivations and that is the implicit derivation. Now look, your template type. Okay, so template, and we said type, we don't know at the beginning what different type of the type is goes inside this. Okay, so depending on the available type, it try to tune the that particular functions or the member of that particular class. Okay, so that is the idea behind that. So let me FVM. So inside the FVM we have a dt, d2 dt, divergence, Laplacian, and this it is about FVM, FVC. Okay, it has a so many things here. You can calculate all these things with the help of explicit derivations, some implicit derivation, some explicit derivations. It's come under FVC and FVM. Okay, so we can check that, and this is how one can see the programming in terms of the FVC and FVM point of view. If it is Laplacian, you can Laplacian of phi, Laplacian gamma phi, in time derivatives. Okay, convections, phi, and this okay, and source term you can define like this way. So if this is the equations, very quickly one can write it down, ddt, divergence of phi of t, and Laplacian of this convection diffusion class of equations. Okay, so when we talk about the basic structure of the OpenFOAM, so normally we can see in application area, this is the things like solver utility testing, then bin folder, basic executable script available, doxygen, library, src, tutorial, and wmac folders. Okay, so this is we already seen from that side. Okay, associated constructors. Okay, so constructor is, so it is a special initialize function that is called each time a new object of the class is constructed. Without a specified constructor, all attribute will be undefined. Okay, null constructor must always be defined, so always we supposed to have a null constructor. Constructor can be used to initialize the attribute of the object. Okay, constructor is recognized by its having the same name as the class. Okay, like in the vector, so whatever we are saying, let's say in the vector, constructor has the same name as a class. Okay, so whatever the name of the class we have, okay, its same name, this is belong to that constructor. Okay, so this is the constructor. Okay, always be there. Okay, overriding constructor. So normally whatever we say initialization and everything, whatever we have for that particular constructor goes into .c file, but in the vector, in place of the .c file, it is available in the, sorry, here it will be defined with the same name, that is the constructor. Okay, and this is constructor, null constructor. Okay, constructor given vector space for same rank, given 3 component. Okay, IO stream, and in the H we are, this is null constructor, 3 vector, okay, component, and the IO stream. Okay, so we are declaring it inside this file. That is what we say. Okay, copy constructor. Destructor is always be there. Okay, to whatever the memory is allocated, we have to return the memory, take the memory back. Okay, so inheritance we say discuss. Then virtual members sometime we require. So virtual member function are used for dynamic binding. The function will work differently depending on how it is called, and it is determined by at a runtime. Okay, so with the help of the virtual name, it try to give us the different idea. So let me give you very quick example about the virtual function so you can understand. So let's go to the src and turbulence model. Okay, and inside that turbulence model, let's say LES. Okay, okay, let's go to the here and let's say RANS model. Okay, so this is all the virtual function. Look, okay, so this is the virtual functions. Depending on the call from the particular type of turbulence model, it try to do the things. Okay, so whenever there is a virtual, okay, it is a return the effective viscosity. Okay, but it is depending on for which particular call, like virtual and the correct. Okay, so now we have a RANS model. So inside the RANS model, if you go, okay, let's say k omega model. Okay, inside the k omega model, when we say .h file, okay, so RANS model.h file is available. It facilitates that virtual call of its member functions. Okay, so this is the, it's all the protected members. Okay, public members, it is access from the outside. This is a destructor. Okay, and here is the same. Look, virtual void correct. Okay, so same way in the RANS, virtual void correct, and so virtually we try to inherit that feature and then we declare it in the .c file. That is the idea behind that. Okay, so this is the .correct is here. Okay, so here we say virtual void correct, it not going to return any argument from this. Okay, and try to calculate things whatever is needed, and from here we say correct newty. Okay, so that is how the virtual functions is available. chosen turbulence model, exactly what I am saying. So depending on the dynamically development or selection of turbulence model, that function going to change. Okay, then abstract class, a class with at least one virtual member function that is undefined is the abstract class. Okay, like the correct is the abstract class for the that particular functions. Okay, then templates. So as I told you, template of T, template class is defined by the line in front of the class definitions template, and depending on the T is a generic parameter. Okay, it try to change. Okay, type define, we can define the particular variable with the different class of the things. Okay, so that is what we can see in terms of the OpenFOAM and the C++ is concerned. Okay, so I suggest please go through this few entries from this particular book and have an idea about the C++ and its basic aspect. Okay, so this is not a C++ class, so we didn't went in detail about very sophisticated aspect of the C++, but we want to only explore what is available in terms of the C++, and that is linked with this OpenFOAM. Okay, so that is the basic idea behind that.